Hey man, in this video you and me will build a SaaS API together, and what that means is basically an API that you can take, that you can add your own ideas to if you want, and then take it and publish it as a SaaS product. So for the idea for this video, I wanted to come up with something that's both relatively easy to program and something that solves a really common pain point of people, and I came up with an idea that I think is pretty cool. And that's JSON API, an API that takes in any kind of unstructured data like a string and turns it into JSON output exactly how you want it. For example, you send the entire HTML string of a website to this API and it extracts the title, the metadata, and basically everything you want from that website data. The main two tools I want to teach you in this video to achieve that are first Zod, a super useful schema validation library that allows us to parse any kind of data to make sure that the data that we work with is exactly what we expect. And then secondly, a retry mechanism we're gonna implement from scratch. Basically, if the conversion fails for any reason, we're automatically going to retry until we get the data to send back to the user. So the user always gets the data that they expect. So you're going to learn a lot about promises, about schema validation. It's just a really fun project to do together that afterwards, as I said, you can implement your own ideas and launch it as a SaaS if you want to. So dude, let's get started in coding this out step by step together. We can do it in less than an hour and I really hope you're going to learn a lot. So let's go. All right, dude. So welcome and let's get started implementing this together. And it's all going to start in our terminal, or you can just create, like a new folder on your desktop. I usually do this in the terminal to create a new project. So what we're gonna do is say in our terminal, first off, we're gonna navigate to the location where you want this project to live. For me, that's the desktop. Anywhere works, like it just really doesn't matter. And then we're gonna say pnpm dlx. So we're using the pnpm package manager. Of course, that's the same thing as if you were using the npm package manager, which would be npx. Same thing. This just installs all packages with pnpm by default, which I personally like, but it doesn't really matter. You could use yarn, bun, it doesn't matter. And we're gonna say create next app at latest. Now, why exactly do we need Next.js for this and not just any other server? I'm gonna get to that here in a second to explain that. First off, let's give this a name. So I'm gonna call this JSON API. And that's it, right? You can leave it as that, but I already have a folder because I prepared this project, obviously. So I'm just gonna name it -2, but you can just name it JSON API or whatever you want, right? It doesn't really matter. And that's gonna ask us some questions to get our project started. Would you like to use TypeScript? Oh, hell yes. Yes, we do. Would you like ESLint? Yes, for code quality, that's a good idea. Tailwind CSS, yes, it really doesn't matter in our use case because we're not going to use it either way, but Tailwind is nice. Would you like to use the source directory? Yes, we do. And the app router? Yes, we also want to use that. And no, we don't want to configure the default import alias. So really quick, while that's installing, why are we using Next? And wow, that was really fast. All right, let's cd into our JSON API-2 that we just created. And by saying code dot, all that does in the directory is open this project up in VS Code, right? You can just do this through the UI in VS Code. It really doesn't matter. Just open up this project, and that's just a little trick to do it a bit easier. Now, why Next? Why can't we do this in Express, in Ruby on Rails, in Flask, in any other server-side framework? And the answer is, well, we very well could, right? It definitely works. This is how I would personally do it if you were to turn this into an actual SaaS, as I mentioned in the beginning, which is, a really good idea because this is a super valuable thing to a lot of people that you can easily turn into a SaaS. And if you wanted to do that, I personally would go with Next and not keep my front and back end separate. So I think Next is a good fit for this project. You could use Cloudflare, any other framework. As I said, totally flexible, and moving it over is going to be very easy once we're done with the project here. So what we're gonna do inside of Next is navigate into the source directory, then the app directory, and let's quickly create a new folder in here called API. And inside of here, one more folder that's gonna end up in the actual URL of the API. That's gonna be the JSON folder. Great, and that's basically it. One more file, route.ts, let's call that file. And that's gonna contain the actual code that will handle the API request to localhost 3000/API/JSON. So the route.ts, it doesn't end up in the URL. It's not /route. This just handles the logic. So if we were to just check if this works, let's export a const, and let's call it the HTTP verb that we wanted to listen to, which is gonna be get in our case. And let me quickly disable GitHub Copilot here. And that's just gonna say return new response. And by the way, you don't need to follow along with this. We just want to make sure that we set up everything correctly right now. Let's write the get handler in here. Let's start up our development server, which is gonna spin up on localhost 3000. And then let's quickly check if we set up everything correctly. So what should happen now is once we make an HTTP request to this endpoint, which is under HTTP localhost 3000/API/JSON. Let's hit enter. There we go. We get the OK back, which means this handler is actually listening to requests properly. We can see the response also right here in our logs, which just means we set up everything correctly. Perfect. So we know our API works now. All right, but the final API is not going to listen to GET requests, but instead it's going to listen to POST requests, because of course we expect some body data. That body data we can grab from the incoming request, which is a parameter that we can receive in the post request route right here, automatically passed in by Next.js. And this will be of type next request, which basically we could also type this as a standard web request, but Next.js does extend it a bit. So this type is technically a bit more accurate if we want to get into the kind of Next.js specifics of the request. Now to get the actual post request body, that's going to be equal to the await rec.json. So we expect JSON requests to be made to this API. And of course, in order to be able to use the await keyword, we also want to mark this handler as asynchronous. And for now, let's just log out the body right here. Let's console log that to see if we set up everything correctly. And let's make the same call request. This time, we're going to make a post request to this endpoint. And as the data, we can say hello world, for example, and hit enter. And let's see if we can see this console log in our console. And we cannot. But yeah, okay, that's exactly as we expected, because we're not making a application JSON request. If we were to just receive the standard text and try that request again, bam, we get the OK, and we also get the hello world body logged right here. Perfect. Okay, of course, instead of text, we do want JSON. We just want to make sure that the post request works correctly, which we know it does now. Very, very nice. And now, what is the first thing that we want to care about in this API? As you saw in the very beginning of the video, in the demo, there's going to be two things we expect in our post request, right? There's going to be the data, which is going to be the unstructured user data that we will convert. And there's going to be the format that the user expects the data to be output in once our API is done, right? So there's the data and there's the format. And now let me show you a really cool tool that allows us to parse the incoming request and make sure that both the data and the format are present in the request. And otherwise we will just reject the request, of course, right? And that tool is called, let's say, npm install or npm install yarn add, it does not matter, Zod. Zod is a schema validation library. You might have heard of it. Let me open up my browser here and go to npm and show you. So it's called Zod. Let's navigate here, and there it is, a TypeScript first schema declaration and validation library with static type inference. So it works very, very nicely together with TypeScript. It got 10 million downloads, so chances are you did hear of it, and it's just a super powerful tool with a lot of options, some of which, like the pass-through, for example, we're gonna take a look at in this video what they do. I've worked with it for a long time, and it's just a fantastic tool that also makes our API more secure, because we can now ensure that this is present in the incoming request. How do we do that? Well, let's get started. Let's just get implementing, right? Let's declare a const and let's call it the generic schema. And this is going to be equal to a Z, which comes from Zod. So that's just a convention, right? It's called Z. You could rename it as Zod, for example, and then always type Zod dot whatever. But convention is to just call it Z. That's what I always do in my projects. And let's create a Z.object. And inside of this object, let's define two properties. And those will be these properties right here. So the data, which is going to be a Z.string. So the incoming unstructured user data, we always expect to be a string, like an HTML string that they parse from a website or anything like that. And then the format, which is the user-defined format that they want the data to be in once we return. right? This is gonna be a z.object as well. And dude, a fly just flew into my face. Get out of here, man. Anyways, this is gonna be a z.object as well. Perfect. Now the thing is, I want to show you a very, very interesting behavior of Zod right now. So if we were to parse the incoming body, let's say for example, generic schema.parse, which is a method we can call on the schema right here, .parse, and we're gonna parse the body. Right, and let's save the result to, let's say, const dress. And I just want to show you what this does, okay? Let's log out the response, because right now this would not behave as we expect it to. So let's log this out, and I want to show you what happens right here. So I'm gonna open up an HTTP client that just allows us to make requests to this a bit more nicer than curl. I just think it's a bit easier to see here. Can we close out of the sidebar? I don't think we can. Anyways, so the request I'm gonna make is this one right here with the data of hello, I'm 35 years old. By the way, if you're wondering, no, I'm not actually, but just as an example. And the format where we expect the age as a number to be returned back to us. So what do we expect to happen? The data will be this. And then we expect the format to be the age with a type of number. But that's not gonna be what happens. So let's try this, right? Let's send this request. Bam, I'm gonna hit the arrow here. And by the way, if you're wondering what this HTTP client is called, it's called Bruno, but you can use Postman. You could just hard code this right here in your code. You could just say the data, const data is equal to whatever, and then pass that right here instead of the body to just kind of mock it out, right? All I want to show you is right now, check this out. The format is an empty object. Right, even though we clearly specified the format right here, it should be age, type, number, but it's an empty object in our API. Why is that? Because by default, any property that we do not declare in our schema in Zod is stripped from the incoming request data. And that's not what we want. We want the user format to be passed through. And that's exactly what I meant earlier, which is why we're going to use the .passthrough. So check out what the difference is, right? If I now make the same request, any property that is on the format will now be simply passed through right here. Why do we need this? Well, basically for security reasons, right? If this is not present, then we want to strip anything else to avoid unallowed properties. In our case, we expect those properties though, we want them, so we need to explicitly tell Zod to pass them through. So we actually receive the user typed format and the data as a string, right? So perfect. We can now make a request with our data and the format, and we now know that we will always have these properties. And if not, then we are automatically throwing an error. That's what Zod does, right? If you didn't want to throw, you could use the save parse right here and then handle the error accordingly. But we actually want to throw and just return an error from the API if the data is not passed as we expected. And the beautiful thing is, because Zod works so well with TypeScript, we now know that we have the data and the format once this is successful, because remember, otherwise we throw, right? So if this is successful, we know we will have those two and we can simply destructure them from the operation. How cool is that? Right, so it works super, super well with TypeScript. Now the next step is, that was step one, right? Step one, make sure incoming request is valid, right? That's basically what we're doing here. And now comes step two, create a schema from the expected user format. So whatever the user passes in here, right? For example, the age of type number, basically we want to turn that into a Zod schema for the same logic. Once we have the schema, we can then parse something against the schema to make sure it matches the JSON format. In this case, we can create a Zod schema from the expected user format. And once we get the response from the AI later, then we can parse the response to make sure it is exactly the expected JSON. And if it's not, then we can retry, right? That's what the retry mechanism is for, which is going to be a really fun part of this build, by the way. So how do we declare this schema from the expected user format? Let's call this the dynamic schema. And this is going to be equal to a JSON schema to Zod function that we're going to create together, in which we simply pass in the expected user format. Right? And then this magic function that doesn't really exist yet is going to turn this user format into an actual Zod schema that we can then use for parsing, right? And if you think that this is some black magic that's going to involve a lot of logic, it doesn't. It's pretty simple, in fact. So let's create or JSON schema to sort function right up here. And this takes in a schema, and let's type this as any. Now, is that a bad practice? No, in this case, the schema can actually be anything. It can be a string, a boolean, it can be an object, an array. We really don't know. We could also use the unknown, by the way. I just use any instead here. It doesn't really matter. Both kind of achieve the same thing here. So this is actually a really valid use case for the TypeScript any. Of course, normally you try to avoid this in your code, but in this case, it makes sense to use it. Okay, so first thing we're gonna do is to define the incoming type. Because we don't know what type the schema is, if it's an array, boolean, whatever data type it is in JavaScript, right? We need to know that type. To do that, we can declare a determine schema type function, schema type. Don't worry, really simple function as well, and simply pass in the schema. All this does is what type is the schema. So if it was a string, boolean, number, and so on. Pretty simple logic for that. So let's declare that function as well. Let's say const determine schema type is gonna be same thing. The schema could be any, and now the all we're doing here is if we have any kind of object, imagine any property in here incoming from the user format, all we want to do is to append the type with whatever type we are receiving for the schema, right? So for example, array or object or string, it doesn't really matter. We want this object to have a type property with the corresponding type though. That's the important thing, right? And achieving that is really simple. We can simply do a conditional check. If not, schema dot, and now we need to check, does it already have a key in the object named type, right? And that's easy. Schema dot has own property. There's a JavaScript function we can simply use for that, and we want to check for the type key in the object. If that is not present, if the object does not have a key named type, then we want to add it. And what's the value gonna be? Well, if this is an array, if array.isArray, that's how in JavaScript we can check if something is an array and pass in the schema, right? So if it's something, oops, let's open this up. If it's something like, I don't know, hello and well, then this, of course, you can probably imagine, right? It's pretty simple, would be flagged as true because it is in fact an array. Wow, surprise, right? And if it's an array, in that case, we're gonna simply return the array. In that case, all that happens is we're adding a type array to the object that we can then check on later, right? And else we're simply gonna return, oops, the type of schema. So in order to not have like a super long if statement, if like type of string, then we're going to return string, and if type of number, then we're going to return number, and so on. This is just a really simple, better alternative. We can just return the type of schema. So this would be string or number or all the other primitive types, right? We can just use that syntax. It's much cleaner. And so the end result will be, we now know the schema type, right? Type array, type string, and so on. Perfect. We can now work with that to determine the sort type that we want to create accordingly. And that's exactly the reason why we determine this type. We can now create a switch statement on that type. And if we have case string, for example, by the way, fully TypeScript safe, type safe, we know the type will be any valid data type in Java or TypeScript, right? So we can simply get a fully type safe switch statement. For example, let's check for the string. So the current incoming user format property is a string. What do we want to do? Well, we want to create a sort schema for this property that is a string. So in our case, we're gonna return right here a z.string.nullable, because this could also be null. If, for example, why could this be null, Josh? You might wonder, right? If the text that the user sends, the unstructured data, does not contain the information that we're looking for, then the LLM is instructed to use null as the value. So for example, if I say, I am 30 years old, but the user format that they expect is gonna be like name, and then as a string, for example, they want to know a name from this data. Well, the name is not in the data. We don't know the name. So what the LLM will output is this. The name is null. It cannot be determined. So we need to allow for that in sort. That's why we use the nullable right here, right? And very similar for case number. You can probably imagine we're going to return a z.number. nullable. And by the way, let's not forget the colon here. So all we're doing is taking the original user format that we're passing in. This one right here, right? So if this was the format, let's kind of create a comment here so I can show you, what this does. And that just looks horrible. Give me a second. There we go. Okay. So this is the there we go. This is the original user format, right? All we're doing is constructing a Zod schema from it, where basically everything remains the same, but the actual value right here will be like a z.string that we can then use for parsing, right? So if the type is, or number in this case, right, this would be a z.number that we expect this property to have, so that in the end we know once we return some data from this API, it exactly matches the user defined expectation of what the data should look like, right? We do that using Zod. And with that logic down, it's simply a matter of typing this out. If we have a Boolean, in that case, we're going to return a z.boolean.nullable, right? If it can't be determined, we instruct the AI to say null. If we have an array, in that case, we're going to return a z.array and simply recursively call our schema. So we're going to call the JSON schema to Zod right here with the schema.items and also declare this as .nullable in case the array cannot be determined. Why are we recursively calling this? Well, for any item in the array, this could also be an object, right? So we don't have to write any logic for that. We can simply call this function again. And it's gonna do the same thing until we hit the primitives to get from the AI, right? So this is just beautiful to implement like this, because we just save ourselves so much work, right? We can recursively call the function and it literally just works, right? Awesome. And now the last case in which we have an object, right? That's a bit of a special case. What we want to do in this case, in the object case, is first let's declare a shape. And this shape will be of type record, so an object that maps one thing to another, and it will map a string to a Zod type any. Right? And we can just default this as an empty object. We're gonna add to this later. And by the way, we also need to import the Zod type any right here in order to make this work. And now let's go through each key of the object. So if you're const, you don't have to follow along. I'm just showing this to you. If the object was name type string, right? We want to go through each key of the object. This would be the value. This would be the key of the object, and we want to go through each key. So if there was like a name, an age, and so on, right? Key 1, key 2, and so on, right? And we want to go through each one. How do we do that? We can declare a for loop, and for const key in schema is what we're gonna say right here. So for each key of the object, what do we want to happen? If the key is not equal to type, because type is an internal key that we use to determine the actual data type, right? It's reserved for our API. If the key is not typed, so we're excluding that from the loop pretty much. In that case, the shape at the index of key, so we're kind of copying the keys over into our shape, but then mapping it to the Zod schema, right? I'm gonna show you an example here in a second, is gonna be equal to, again, JSON schema to Zod right here. And we're gonna pass in the schema at the index of key right here. Might seem a little bit abstract, but if you kind of take a look at this, and then you realize all this does is if we had a name type string, right? For example, as the user expected format, basically all we're doing here is converting this to name. The key remains the same thing, right? Shape at the index of key. The name is gonna be then the Zod schema for the data type. So in this case, like the string, right? This is just pseudocode, but you get the idea. This is just, I mean, under the hood, this is like a function we can invoke and so on. It's a bit more complicated, but essentially we're turning some proprietary syntax right here into a custom Zod schema that we can actually use for parsing, right? That's all we're doing. The keys stay the same. And now we can use this object, this shape, to actually validate at runtime using Zod, which is beautiful. And lastly, we can simply return the z.object right here. And of course, in here, we still want to pass our shape. Perfect. And that is the logic. Now, what if a data type is not handled, right? If it's neither a number, nor Boolean, nor array, nor object, and so on, if our switch case basically doesn't match anything, well, in that case, in the default case, we can define at the very bottom, we can simply throw a new error and say unsupported data type. And then we can append the type that we have, right? Whatever that might be. Oh, and that is giving us an error. So instead of just doing it like that, let's quickly change the syntax here to a template string and then insert the type right here. That works. There we go. Okay, perfect. So all this does is alert us at runtime. So we can see this in our runtime logs to debug if we wanted to, if there was any data type that did match. But of course, this should really realistically not happen because we are handling all the data types before this, right? Object, array, boolean, and so on. Perfect. Very, very good job. So what this does is now we can dynamically create a schema from the incoming format that we can use to parse whatever the AI gives back. And if that parsing is successful, then we know that the JSON created by the AI is exactly what the user expects, right? So perfect. Now the next step is one of the most fun of this build, and that's creating the retry mechanism. It's very important, right? If you want to have robust functions in your app, then chances are you're going to need some kind of retry mechanism. If that's an external service, if that's something you write yourself, like we're going to do right now. Anyway, it's very, very good to have in your app to have retry mechanisms because it makes your app that much more robust. Let's kind of sketch out the API. Step 3 is going to be a retry mechanism. How do we want this to look? How do we want this to work? Well, basically, let's say const example. Let's just declare this as any kind of function. And then basically the implementation that we want to write is something like this. We want to have a retryable promise. Let's name it that. And let's go ahead and create that first, okay? Then we can think about the rest. Let's create a class retryable promise. And by default, this is not gonna do anything. And now let's get to the next step. So this is how I always do it. I just kind of sketch out the API, how I want it to look, and then implement it later or as we kind of sketch this out. On this retryable promise, we would like to have a .retry function, right? I think that's a really intuitive API to create. However, our retryable promise does not have that kind of functionality. So let's add it. First thing we're gonna do is to extend this by the promise, and this should be extends. There we go. And this promise always takes a generic T, and we can just receive that generic T, uppercase here in the retryable promise as well. And all this does is basically now all the functions or all the methods we have on a normal promise, like raise, reject, resolve, and so on, we also have on the retryable promise because we extend the regular promise, right? But there's still no retry function on the promise or on the promise class that's in JavaScript by default, right? So we have to add that ourselves. We're gonna define this as a static function, and all that does is we can now directly call this function on the retryable promise, and we don't need to instantiate a new class altogether. It's just a bit nicer to do this. There we go, static. And then this is also gonna be asynchronous because we're gonna handle some logic in here regarding promises. And of course, we already know the name for this function. It's gonna be retry right here. Let's create the function and open it up. And that already gets rid of all the errors, right? We can now call the retryable promise.retry, which is great. How do we want the API to look like now? What should happen? Basically, the best thing I can think of is we are going to have the amount of retries, like 3, and then the function that we want to retry that many amount of times, right? I think this is a really easy to understand API. Retryable promise.retry, amount of retries, and then the function we want to retry. Right, you can take a shot every time I say retry. You're gonna be hella drunk by the end of this video, probably already, right? But that's how it works, right? I think this is a really nice API to work with, and that's how we're gonna implement it. Now, of course, this is gonna give us an error. This doesn't currently accept both the retries as a parameter right here. So let's accept it. This is gonna be a number, and then also the executor. So the executor, there we go. So the actual function that we want to execute and retry this amount of times, right? And all this is basically just a function that returns void, or at least that's what it would be in our example right here. But one thing this doesn't account for is what if anything goes wrong in the example, right? When do we want to reject or accept this promise? Well, that is done in the example. We want like a resolve or reject property in here, and then use them in our function to determine when do we want to retry, right? So if anything, if this and this, then we want to reject the promise and go on to the next retry, right? Currently, there is no mechanism for that in this implementation. Therefore, the executor actually looks a bit differently. Let's declare a custom type for this, and let's name it the promise executor. There we go. And then this type, don't worry, it's going to be very, very simple. Let's define it right up here. The type promise executor. There we go. This is simply going to contain a resolve, and this resolve is going to receive a value t, let's name it, so a generic, and simply return void. And this will also contain or reject. And this reject can have a reason, right? If we do want to pass that, but that's optional. Let's just make it any. This is also going to return void, and then the entire promise executor is also going to return void. We don't expect anything from the function. Now, because we assigned a generic t here, we also need to, well, declare that generic, right? And that is done right here after the promise constructor. So basically, we're telling TypeScript, hey, there's going to be any kind of generic in this promise constructor, and this is going to be the value of the generic, in our case, the value of the resolve that we pass in. And now the reason we're using generics is going to become very, very clear later. And that's going to be so we can type out what the result of our promise will be, right? This is the only reason. If we didn't want any kind of type safety, we could totally just type this value as any, right? But I want to show you how to do this properly with type safety in mind, because if we didn't have the generic, then we wouldn't know the output of our example and get type safety for the return value later, right? If we just assign this to anything, this promise is void. But if we had any kind of logic in the example, and this would return, for example, hello world, then we wouldn't get any kind of type safety in our function right here, right? So that's the reason we're using the generic t right here. I think it's going to become a bit more apparent once we actually use it later on. Let's just implement it for now. And if you don't fully understand it yet, don't worry. It's going to become very, very clear in a second here. Now, of course, we still need to pass in the generic wherever we call the promise executor right here, right? Because this does now expect a generic. This is going to give us another error, right? Lots of errors right here, but that's normal when typing stuff out. Static members cannot reference class type parameters. Why do we have this error? Basically, because we didn't declare the generic here on the retry function either, right? So this is where we declare, hey, we're going to have a generic. And this is where we're telling TypeScript this will be the value of the generic, or at least that's the mental model that helps me understand generics. And maybe it does for you too, right? Perfect. So let's open this up. We have the amount of retries, so in our example 3, and we have the function that we want to retry that amount of times, which in our case we called the executor. Now the beautiful thing about our retry mechanism is, what if promise 1 fails? What if it's rejected, right? If anything goes wrong in the promise, well, basically we want to move on to the second retry. How do we do that? That's the beautiful thing. We can simply recursively call this retryable promise with the retries -1. You see, like that's really, really cool. Let me show you how that works. Inside of our retry, we can simply return a new retryable promise. Wabam! We're gonna pass in the executor. There we go. And we can simply catch any error. If anything goes wrong, well, then we want to retry. We do get access to the error right here, and we can use that, for example, to log something out. So let's say, for example, console.error. And in here, let's create a template string and say retrying due to error, and then simply insert the error right here. I think that does the job. So we in the runtime logs can see whatever went wrong. But now for the more important part, if let's return, the retries is larger than 0. So if we're not at the end of how many retries we have in the retryable promise, then we want to retry, right? So we're going to do a ternary check. If this condition is true, right? If we still have retries left, in that case, we're going to just return the next retryable promise. We're going to move on recursively, as I just talked about. We're going to call the retryable promise dot retry with the retries -1, so we can just decrement it by 1 and simply pass in the same exig. It's a hard word for me to spell. English is not my first language. Anyways, and if we have exhausted all retries, right, in that case, we're going to say retryable promise dot reject, and we can call this reject because we extended the regular promise, right? This is not a custom function on a retriable promise. This is something that all promises have by default, this reject function, so we can just call it, right? If we had a new promise dot, and then we can also call the reject. You see where it comes from? This, or this is where it comes from. Beautiful, so we can just reject with the error. And TypeScript is still complaining, it does that a lot, trust me, but let's finish the typing and it will stop. So first off, let's declare the return type for this function, which we know is a promise, right? So let's just annotate the return type right here. That's gonna be a promise. And because promises always take a generic, we need to pass the generic in here. And wha-bam, like magic, TypeScript stopped complaining. Well, finally, right? And that's how we implement a beautiful retry mechanism that works recursively by calling the same class method again, which is the retry, and simply decrements the amount of retries. So whatever we now pass in at the retries is gonna be how often this function is rerun until we resolve the promise, right? And if we reject it at any point, then we're gonna move on to the next retry. Beautiful, very, very nice. That is TypeScript work done. And what that allows us to do now is in the callback function that we pass into the retry, we now receive two things, the resolve and reject. And whenever we call them anywhere inside of our function, right, let's open this up. We can always choose when do we want to move on to the next retry by rejecting the promise, or when are we done? When did we get the correct result by resolving our promise? So conceptually how this looks, check this out, is let's create a try catch block here. And in the try block, we're gonna call the AI with the input, the unstructured data, and then also the format that we want it to be in, right? And if, let's say the const res of the AI is gonna be, I don't know, it's gonna be JSON, right? That's what we expect. And let's say the name is gonna be in single quotes John, so we can have it inside of double quotes. There we go. Let's say that was the AI output, right? Next step is this the JSON that the user expects, right? Validate JSON. We already know how, because we literally have implemented that. It's our dynamic schema, right? So what we can do is declare a const validation result is going to be equal to dynamic schema dot parse, and we're going to parse the AI output that comes back as a string, right? So we still need to parse that into a valid JSON. We're going to pass in the response right here from the AI, right? And only if the AI response matches exactly the user format, if this parse operation is successful, only in that case, we can return, resolve, and pass in the validation result, right? We know this is valid JSON, this is exactly what the user wants, so give it back to the user from our API route. And if this operation is not successful, we're automatically going to land in the catch block, because that will throw. And so in the catch block, we can tell our retriable promise by rejecting with the error to move on to the next retry and try this whole thing again until it works, right? Until the AI gets the JSON right. Great. And let's try out if this works. And maybe before we do that, let's rename the IDK, which I always do in my projects. If I don't know what a variable will be, I just name it I don't know. It's just a habit. But let's call it the validation result, because that's what we are resolving the promise with, right? And we know this will be an object, so we can pass that in as a generic. This will be JSON, right? Because we're passing it, parsing it, not passing it, parsing it. This will be JSON. We are resolving the promise with it and thereby assigning it to this variable right here that we get from the retriable promise. Awesome. And to give that back to the client, to whoever is calling our API, we can simply return a next response and import that from next.server.json, because we're going to be passing back an object. This will automatically be serialized, right? And then as the status, we can send 200. Everything okay, everything worked perfectly. Very, very nice. Let's save our route. And of course, what we expect to happen right now is for this to fail, because this response is not actually valid. I mean, the response is valid, but it's not what the user expects, right? We expect an age that's a number, but what we get is a name that's of type string, right? So if we were to call our API just like this, we expect this to fail. And dude, that was not the kind of error that we expect. Like, we did expect this to not work probably, but there shouldn't be an error, right? So I did some debugging really quick to find out where the problem was. And I found one thing First off, we forgot to define a return type for our JSON schema to Zod, so this is currently underlined red. This is just a TypeScript thing, right? It's not important, but this does return Zod type any, because after all, we are returning any kind of like number, string, boolean, any kind of Zod type. So that's just to make TypeScript happy. And one thing we forgot is to handle the other case. If it already, like if a property, if an object already has its type property, well, we can simply return that. Let's return the schema.type because we know that property already exists on the object, right? And with that in place, let's try this again. I already prepared the HTTP request here. So what we get from the AI, right? If we scroll down here, is a name of John, right? And we're parsing that and then seeing, is that the expected user format? So let's try this. If we send out the request, we get back an empty object. Very, very nice. And if we had something like the age, which is a number in here, then we would get retries, because this is not the expected format, right? So let's try this again. Let's send this over. Okay, really quick intervention. No, that empty object is actually not what we expect. I thought it was once I recorded the video, but actually what we expect would be a null value in this case, right? As the API output, because the data is not given in the data string that we want to format to. We're gonna fix that later, right? Let's just continue as it is. I just wanted to make sure that you understand, no, technically the empty object is not what we expect, but we're gonna fix that in like, I think 2, 3, 5 minutes, whatever, into the video, just so you know what's going on here. So let's continue. And that's exactly what we can see in the code right here, retry due to error. And it does that as many times as we want, right? So in our case, that was, I believe, 5 times. It's retrying again, and so on. And always the age is the problem, because of course it literally, that's what we're forcing right through this kind of hard-coded response right here. So we know the retries work. Very, very nice. We know that we can only send back data that the user expects in the correct JSON format. Perfect. That's exactly what we want as well, right? So the last step in getting this to work in, if you want to publish this as a SaaS, you very well can, is to actually integrate the AI. Right, and you can choose any AI. I was kind of unsure which AI I should use for this video to make it easy for everybody to follow along. I settled on OpenAI, but again, you can use any kind of AI. You can go to, let me show you that. You can go to replicate.com if you don't have an OpenAI key, not replace, replicate. They have a ton of AI like Meta's Llama AI or open source AIs. Whatever you want, you can use replicate to make the AI request. You can use OpenAI as we're gonna do. It really doesn't matter, because after all, they're all pretty good at this kind of thing. What we're gonna do is go to platform.openai.com. And after you create your OpenAI account, I'm not gonna log in here, but you're gonna have the API key section on their website, and you can just generate yourself an API key and use that to interact with their models, right? I believe most of you are familiar with OpenAI. That's why I chose it. But again, you can literally use anything else, open source models that just require a replicate API key. I'm not sure where the search is here, but they also have like text generation right here, Llama 2, 70 billion. They also have Llama 3 as far as I know. Or that was somewhere else, I'm not sure. But again, any AI works, totally flexible, so everybody can follow along here. And we're gonna use OpenAI just as a demo. So once you grabbed your OpenAI key, let's install the helper library to interact with it. npm install OpenAI, which is an open source. Is it open source, by the way? I'm not sure. Let's quickly check that. Is what I'm claiming correct here? Is OpenAI SDK open source? I think so. Okay, it is. Great. So it's an open source repository to interact with the OpenAI SDK in a types of, or OpenAI API in a types of way, which is great, right? So we can simply install that helper. Let's go into our file system here and create a new folder in our source folder called lib, and this stands for library. And the convention here is to prepare libraries like OpenAI, for example, to be used in our project, right? That's conventionally what this is for. And to get started with OpenAI, it's by far the easiest. That's why I chose it. You can import OpenAI from OpenAI just like that, and then export a const OpenAI in lowercase, which is going to be equal to a new. And this right here, this OpenAI is a class that we can simply instantiate right here and pass in our API key. And this is where the API key goes that you grabbed from the OpenAI website if you're following along with them, or basically any other AI that you want to integrate, right? Again, it really doesn't matter. And you can find a ton of guides on how to use open source alternative AIs for this, so you can follow along. Right, so what I'm gonna do is I'm just gonna grab my API key here from the right side and paste it in here. Of course, I don't wanna leak the key, so I'm just gonna quickly cut this out, and that's gonna allow us to just integrate the OpenAI API in this. So I'm gonna paste this in right here, close the file, and be right back. Beautiful. So with that done, the res that we have right here is gonna be equal to await, and we can now call OpenAI .chat.completions.create. That's basically how we can make a request to their models. And by the way, in order to await, we can also mark this as an asynchronous function. There we go. Now the model that we're going to use is going to be called GPT-4o because it's a very good trade-off between speed and like smartness of the model. It's a very, very high performance model. And the messages that we're going to pass in here is going to be an array of messages. The first one is going to get a role of assistant. And by the way, if you notice, wow, fully type safe, everything here, right? Really, really nice. And then the content of this message is really important. That's gonna give the model an idea of what it's meant to do, right? So let's write this together. Let's say you are an AI that converts data into the attached JSON format. You respond with nothing but valid JSON based on the input data. Your output, and this is important, should directly, let's put that in caps, be valid JSON, nothing added before and after. There we go. You will begin, and this is also important, with the opening curly brace, so the first letter in JSON always, and end with the closing curly brace. And this is just to avoid that the model gives us any text before or after the output, right? So we can parse the output right away. Only if you absolutely cannot determine a field, use the value null, right? So if we are asking the model for a name, but all that's given is the age, for example, then it's gonna be null, right? Perfect. And that's the instruction to the model. Maybe, I mean, this is not set in stone, right? This is what I came up with. This works very well. Maybe you can find something that works even better for your SaaS if you want to publish this, right? This is just what I found out works pretty well. Now let's give the model an example, right? So we're gonna attach a second message right here. The role is gonna be user, and then the content is gonna be, well, we could put just a string here, but let's actually move this to a second file. Let's keep this separate. I think that makes the maintenance a lot easier here. Let's create a second file in our JSON API folder, and let's name this example.ts. And all we're doing here is creating two constants as examples, right? So the first one is going to be, let's export const example prompt, and then later on we're also going to have the example answer, right, to give the model an idea of what the hell the output should look like, right? And these examples are just strings, right? So there's no point in typing all of this out. I want you to learn how to write really good code and not how to stupidly type along with me, right? So I'm going to prepare the example prompt and the example answer for you. All you can do is just grab them from the copy paste list. I'm going to attach in the description of this video. You can just grab them and let's just, paste them in here. There we go. So we have the example prompt and the example answer. Again, it's just a string. You don't learn any code from this, so I don't think it's worth spending time on this. I want to save you that time, but let's quickly go through what this does, right? Basically, we have the data, then the user-generated input, the unstructured data right here, and we're separating that from the expected JSON format, which is the format that we want the output JSON to be in, right? What the user expects. And then we just give the model an example of an object that matches that shape. That's what we want the output to be like, right? You could include multiple answers if you wanted to turn this into an even more reliable solution. That is probably a good idea. Do like 3, 4 examples, just like this in different use cases. That's gonna make the output even more reliable. This already works pretty well. So I think 1 is enough for our example here. And perfect, that's the example. Beautiful, man. And with that done, we can simply insert the example prompt as the content for the first message. And then of course, to give the model an idea of how the output should look like, same thing. Let's have a role user, and the content this time is gonna be the example answer, right? So now this model knows a prompt answer combination, and it will respond in the same kind of output format to our actual user request now. So the role for the third or the fourth message, technically, I guess in here is going to be user as well. And now let's define the content. And again, we could define the content inline right here with a string. I generally try to prefer to do this right above here. For example, above the OpenAI chat completion, it's create whatever. This is where I'm going to create the const content. I think this is a bit nicer to declare it here and then simply use it down there than doing everything inline, right? You could also move this to a separate file if you wanted to. It really doesn't matter. Anyways, the content that we want to keep in here is basically the same format as our example right here, right? So let's copy our example. Let's just copy this. Of course, we're going to change some things about it, but the format is going to be the same, where the data right here is going to be the dynamic user data. So let's insert it into these quotes. Let's keep the quotes, but right here, we're going to put the data that we destructure from the incoming request, remember? So this data is nothing else than the incoming post request data that we parsed right up here. Beautiful. Okay, now the expected JSON format, we also know this, right? This part right here is gonna be, let's dynamically insert this, or json.stringify, and in here goes the format that we also destructure from the body. And we can also give this a null and a 2 just to kind of format the JSON to make it easier for the AI to read, right? And then we can leave the rest as is. Valid JSON output in expected format, and then the rest is gonna be up to the AI, right? So as easy as that, we now have an example, and in the same format, the actual user request to the AI. Beautiful. And that's pretty much all the work done. The absolutely last thing that we want to do is to actually get the text content from the AI response. In the case of OpenAI, if you're following along with this, the const text is going to be equal to the res.choices at the index of 0.message.content. If you're following along with any other AI, you can just log out the output and then see where the text content actually is. That's all we care about, the response from the AI as a string. Right? And this text we're now going to use instead of the result. We can just paste it in here and parse it because we expect it to be a valid JSON string. And if it's not, if it's null, which TypeScript thinks it could be when in reality it really isn't. Anyways, just for TypeScript, let's also put or empty string, in which case this would of course fail the parsing, but that's not going to happen. This is more for TypeScript to be happy, right? Beautiful. Dude, let's save that. Let's try if this works. I believe our API should be running, right? Is it? It should be. Yes, it is. Okay, perfect. Let's try this out, man. Okay, so let's open up our HTTP client and make a request to our API. Let's say my name is John and we expect the name to be, a string. Let's try this. Let's send this out. I'm going to make this a bit smaller. There we go. Let's send this to our API. And wow, okay, that did not work. Interesting. We did get a successful response, but we got an empty object. Why is that? Oh, because we have the age right here. This needs to be the name. Let's send that again. And yeah, we get back an empty object. Let me check why. Give me 1 second and I'm gonna see why we get back an empty object. Oh man, okay, and it was the most simple problem imaginable. So one thing I did is move the type and promise declaration, like the class implementation, above the HTTP handler. I think that's just generally a good idea, but that was not the problem. So I just moved it from inside the post handler to above it. But that wasn't the problem. The problem is that we're not awaiting the promise, man. That's literally it. So let's try this. Let's let this load, and there we go. Wow, now it works. If we await an asynchronous operation, who knew it could work? Anyways, okay, so await this promise, and then we get back the actual validation result. And beautiful. So we can't tell the age from the data, right? That's why we get back null. But, oh, that shouldn't be John. That should be the name. There we go, type string. Let's try that. That should be John. Of course, right? Perfect. Very, very nice. Finally, it works, man. And you can put any kind of information, any unstructured website data, web scraping data, social media comments, and so on. Or let's say, I don't know, the battery life of the phone is 24 hours. There we go. And then we can say battery life HRS for hours. We want that to be a number. Let's try that. Of course, we expect this to be 24. There we go, battery life hours 24. And you can have multiple properties in here, of course, in the format nested objects, nested arrays, and so on. And all that's possible because of our JSON schema to sort recursive implementation right here. So we can have nested arrays, we can have nested objects, and so on and so on. And it's all handled by our JSON schema to sort and by our API in general, right? Very, very nice. I really hope you enjoyed writing this retry mechanism together. You can enter like 3 retries or 5, depending on how long you want this to take. And yeah, I really hope you enjoyed following along. That's already it. That's the logic. And you can really build on top of this if you want to turn this into a SaaS business, because I think a lot of people need something like this, especially with so many AI applications popping up. People need JSON, man. It's just a really, really important data format, and making sure that whatever comes back is exactly what the user expects is very valuable. And you can turn this into a business if you want. Build on top of this with your own ideas. I really hope you do, because that's also how you learn the most, right? So I really hope you enjoyed following along, writing this together with me. And I hope you bring your own ideas into this if you want. That's gonna be it for me. I'm gonna do the outro in person. And thanks again for following along. Hey man, I really hope you enjoyed the video. I think this was a really cool build. The idea is damn useful, right? This is literally what I needed in the past. And if there was something like this, I would have used it. And dude, I really hope you can take the idea, bring your own ideas into it, because that's how you learn, right? Build on top of it, extend it however you want. No limit set. Feel free to just take the idea and publish it if that's what you want to do. Totally fine as well. And dude, yeah, I just hope you enjoyed following along. All right, that's gonna be it for me for this video. I'm gonna see you in the next one. Until then, have a good one and bye bye.